Hi, we're from SMJK CHONG.
She's Phang
And she's my partner in learning. And we are from 2S.
Our teacher advisor is Ashkin.
Science is fun and balloons are fun. Why not combine them with a cool baking soda science activity?
It's a must-have for baking soda and vinegar for all year long.
This vinegar and baking soda experiment is a kids' science experiment we haven't tried yet.
So let's get started.
For this experiment, we are going to need a balloon, a funnel, baking soda,
Water and vinegar.
Firstly, using a funnel, add the baking soda into the balloon. Next, carefully feed the balloon over the bottle opening. Be careful not to drop the baking soda into the vinegar yet. Once the balloon is filled, hold up the balloon and allow the baking soda to fall into the vinegar. Observe the chemical reaction.
The balloon is blown out by the gas created. The science behind this balloon baking soda experiment is a chemical reaction between the baking soda and the vinegar. When the two ingredients mix together, the balloon baking soda experiment gets its lift. The gas produced from the two ingredients is carbon dioxide. As the gas goes up into the balloon, it inflates it. Similarly, we exhale carbon dioxide when we blow up balloons.
The second experiment we are going to do is fire-proof balloon.
What happens when the balloon doesn't fill with water and let it touch the flame?
It will pop.
How do balloons fill with water?
Let's try it out. First, I'm going to light up the candle.
Place the balloon over the flame so that the balloon touches the flame. Look, the balloon doesn't pop.
This is because heat from the candle will get transferred into the balloon rubber and whatever is filling the balloon. This is known as heat conduction. When you heat a gas or a liquid, it expands and rises up. It's because the density of the gas or liquid decreases as it heats up. The water within the balloon absorbs the heat from the candle and rises, drawing the heat away from the balloon rubber so that the balloon survives the flame. Once the hot water rises away from the flame to the top of the balloon, it then cools down, dropping back towards the flame to then get hot and rise again. This process is continual convection current, whereby the warming water rises and the cooling water falls. This process helps to keep the balloon from popping by constantly drawing heat away.
The data of our experiment treat is bit of news.
The material that we need is balloon,
pin, and cardboard. Firstly, pop your drawing pins through the cardboard.
Then, lightly push your balloon down onto the pins. The balloon doesn't pop. If you pop the balloon with the pin, all of the pressure is concentrated on one point of the balloon, so the balloon easily pops. When you place the balloon on the bed of pin, the pressure points are spread all across the surface of the balloon. The fourth experiment we are going to do is the balloon skewer. For this experiment, we're going to use a balloon,
Skewer, and oil.
First, I'm going to cover the skewer with the oil.
Starting with the top of the balloon where the color is the darkest. Slowly start to spin the skewer as you gently press on the balloon. Keep spinning until the skewer goes into the balloon. Next, slowly push the screwer to the opposite side, where the balloon is tied off, and as you contain the balloon, start to spin the screwer again, applying gentle pressure as before. The balloon doesn't pop. This trick works through an understanding of surface properties. A balloon is formed by inserting air into a flexible thin rubber sheet. Most of the balloon is stretched evenly, but there are 2 points where the rubber is least stretched, and thus there is the lower surface tension. This corresponds to the tight section and the darker patch at the opposite side of the balloon. In fact, the darker color indicates that the balloon is less stretched over that region. Most of the balloon is under high tension, so attempting to push the screwer through just makes the balloon pop. But at low tension sections, it's possible to make a small hole without breaking the overall surface of the balloon.
It's all for this.
Thank you.